Okay, so hello everybody. We have the big pleasure to continue our conference, and we have wonderful new speakers. And I will give the floor to Sibel Silici to present our next speaker.
Yes, thank you very much, Stefan. I would like to introduce Professor José Maurício Sforcin. He is expert on Propolis. I know your articles, really excellent. I think he presents on Propolis. He present a presentation on Propolis again. Propolis effects on people living with HIV under retroviral therapy. Please. You can share, Professor Maurício. Your voice is close. Could you open your voice, please, Professor Sforcin?
Yes, thank you. Host disabled my presentation. I cannot share it.
Stefan,
okay.
Could you make it?
Yes, so I'll share it from our computer here, Mauricio, and you just say next. Okay?
If you prefer, I can present, Stefan.
But can you make the share screen?
Yeah.
Yeah, try. Okay, do it. Then it's better, much better.
It's written host disabled participant.
Oh, sorry. So my mea culpa. So I forgot to put you because it was after the break. Mauricio, you are Mauricio. Yes, here I believe. Make co-host. Okay. Now it should be okay. Try to make now the share screen.
Is it okay?
It should come.
Did it appear to you?
Not yet. You are co-host, but it didn't appear. So can you restart? You press, the button share screen, and then so you have the PowerPoint show already open, and then yes, now it should come. Yes, now okay, and try to do it full screen. Perfect.
Okay. Hello, everyone. Thank you very much for inviting me for this conference. I'm very honored. And I'm going to talk about Propolis effects on people living with HIV under antiretroviral therapy. HIV infection is one of the major public health problems in the world, with a large number of infected people and new cases every year. The antiretroviral therapy promotes a longer survival of people living with HIV or AIDS. However, they lead to side effects such as cytotoxicity, metabolic disorders, and persistent immune activation and inflammation. In fact, people living with HIV and AIDS have an increased inflammation and immune response deregulation compared to non-infected individuals. Thus, alternatives for improving the health of people living with HIV and AIDS are important, aiming at attenuate the impact of the infection and the side effects of the treatment. The antiretroviral therapy leads to viral suppression. It diminishes HIV transmission. So, people whose HIV is undetected, it means it is non-transmissible. And the therapy leads to protection of the immune cells, and it diminishes the mortality of people living with HIV and AIDS. In Brazil, the current recommendation is the treatment as soon as someone is detected as seropositive. The treatment has occurred earlier and earlier, with earlier onset of therapy side effects such as cytotoxicity, metabolic disorders, bone toxicity, alterations in the cardiovascular, central nervous system, liver, kidney, and pancreas. The infection itself leads to inflammation and immune activation, and together with the antiretroviral therapy, they lead to non-AIDS comorbidities. So there is still a need for new alternatives regarding the health of people living with HIV and AIDS, aiming at mitigating the impact of the infection itself and the side effects of the treatments. Thus, we investigated Propolis benefits for people living with HIV and AIDS on treatment. There are a lot of articles dealing with the biological properties and therapeutic application of propolis, showing that propolis displays an antimicrobial activity, antitumoral, antioxidant, anti-inflammatory, immunomodulatory, but there is the problem of the chemical composition of propolis, leading to a big chemical diversity and a problem for a universal standardization. Thus, in this project, we used a standardized extract of propolis produced by Eps Flora here in Brazil, which has a quality standard with reproducibility, safety, and efficacy batch by batch. And using these propolis capsules, they have the same chemical characteristics and biological properties. There are a lot of preclinical and clinical trials showing the safety and efficacy of this standardized propolis capsule, as we can see here in a lot of articles that were already published. So the goals of this study were to verify the effects of propolis supplementation for 3 months for people living with HIV on treatment and with viral suppression, analyzing the biochemical and metabolic profile, inflammatory and immunological response. This study was approved by the Ethics Committee of our university, by the Biosafety Committee, and by the Brazilian Register of Clinical Trials. This study was a randomized, double-blind, parallel intervention, placebo-controlled clinical trial. The statistician of our university recommended to include 4 asymptomatic participants, and they were divided into placebo and propolis group. They were analyzed in the moment 0. We took the blood and made some analysis, and after 3 months of propolis intake, we analyzed in the moment 1 propolis effects. We had some inclusion and exclusion criteria to include the participants in our research. The inclusion criteria were people from both gender, aged 20 to 55 years old, with HIV diagnosis, on antiretroviral treatment and viral suppression, a T-CD4 cells count more than 500 for more than 2 years, and then they signed an informed consent to participate in our research. The exclusion criteria were pregnancy, anorexia, obesity, transplants, cancer, cardiovascular autoimmune diseases, diabetes mellitus, co-infections, the use of alcohol or drugs, anxiolytics, antidepressants, and vitamin supplementation. So we invited 800 participants to ask if they would like to participate in our research. And in the first moment, most of them were excluded because they did not meet the criteria to participate in our survey. So we had other participants. They were allocated in 2 groups. and some of them lost the follow-up. So we had 20 participants in each group, as it was recommended by the statistics department of our university. First, when they agreed to participate in our research, we talked to all of them separately, explaining our research. We gave them a bag with the Propolis capsules or placebo capsules and some instructions. We gave general information about our research, the importance of our study, and we instructed them how to take the pills. They could write here any symptoms if it was the case, and if they forgot how to take the pills or they didn't take, they could make note of these observations. They also had to register in 3 moments what they ate in the breakfast, in the lunch, in the dinner, and intermediate meals. So when they started taking the pills, they had to write here the day of the first blood collection and when they started taking the pills. We had 3 different moments of their eating habits, and we had the day they finished taking the pills, and then we take their blood once again. We carried out nutritional analysis, such as anthropometric assessment of weight, height, neck, waist, hip, and circumferences. We analyzed the nutritional diagnosis, such as body mass index, body composition by multi-frequency electrical bioimpedance, and also the 24-hour recall and food record. We had some laboratory analysis, and in routine tests, we had the TCD4, TCD8 count, the viral load, biochemical and metabolic markers, blood count from electronic medical records. And we took their blood to analyze in their plasma the cytokines. We also carried out a PBMC cell culture to analyze the cytokines by ELISA, the activation of transcription factors by PCR, and we also analyzed the lymphocyte proliferation by flow cytometry. The design of our protocol and the statistical analysis was conceived by the Research Support Office of the university. So they could instruct us how many participants we should have in each group and which tests should be appropriated to carry out the statistical analysis. So I'm gonna show you now the results of our survey. We can see here the epidemiological, clinical, and therapeutic characteristics of 40 people living with HIV. No differences were seen regarding their age, time since HIV diagnosis, and time on treatment. Regarding the skin color, most of them were white, male, no differences regarding their sexual orientation, and they had different kinds of antiretroviral therapies. Regarding Propolis effects on the viral load and cell count, we can see here in this table that the HIV viral load remained undetectable even after Propolis treatment. And the cell count of all the cells that were analyzed showed no differences during this intervention. Propolis had no effects on the metabolic and biochemical profile of the participants after analyzing a lot of biochemical determinations. So the viral load remained undetectable. This is very good, showing no Propolis interference in the therapeutic treatment. The TCD4, CD8 cell count remained elevated, showing that individuals were stable clinically due to the high T cell count. Propolis induced an increase in the CPK activity and in the magnesium concentration. Propolis increased CPK activity, which has no clinical relevance. Since patients had no myoglobinuria and clinical signs of rhabdomyolysis, propolis may be considered safe with no side effects. Propolis increased magnesium concentration, and magnesium is involved in more than 300 metabolic reactions. People living with HIV on treatment may show a lower concentration of micronutrients, including magnesium. And magnesium deficiency is related to a bad prognosis in kidney and bone diseases and in diabetes mellitus. So propolis contributes with body homeostasis and may improve the prognosis of such diseases. Regarding now propolis effects on the nutritional status and anthropometric measurements, we can see here that propolis did not affect any anthropometric measurements nor nutritional status of the patients. And no differences were seen in the food record of people after analyzing 3 times their eating habits. So there were no changes in the food pattern during the intervention, and people who took propolis capsules had an increase in magnesium concentration. Propolis sustained the adequate viral suppression. Propolis sustained the immune response and led to no adverse events or complaints after the intervention. So our data showed that the daily intake of propolis, 500 milligrams per day for 3 months, is safe for asymptomatic people living with HIV on treatment. Regarding plasma cytokines and PBMC cytokines, no differences were seen in their production. In fact, when we have clinical trials with humans, we can see a high standard deviation. That's why sometimes we cannot see some statistical differences. But when we carried out the cytokine production by cell cultures, one can see here a positive correlation between IL-10, which is an anti-inflammatory cytokine, and the TCD4 cell counts. We also had a negative correlation between IL-10 and interferon gamma production, which is a pro-inflammatory cytokine. So this data indicated that propolis intake is associated to a proper immunity and lower inflammatory status. We also analyzed the transcription factors related to Th1, Th2, Th17, and T regulatory cells, and we could see here an increased FOXP3 expression in the propolis-treated group, demonstrating that propolis modulate the immune response of people living with HIV, leading to an anti-inflammatory profile. We also analyzed the lymphocyte proliferation of placebo and propolis group, and we could see here that propolis increased TCD4 cells proliferation, showing that propolis may enhance the immune response of people living with HIV on treatment. In summary, propolis showed interesting and promising effects with no side effects. It increased magnesium concentration, lymphocyte proliferation, and led to an anti-inflammatory profile in asymptomatic people living with HIV on antiretroviral therapy. Such findings were not associated to social, demographic, and therapeutic features, nor to changes in eating habits. Thus, propolis may be considered a new intervention for people living with HIV, mainly to those with comorbidities or therapeutic failure who were not included in this study. Part of these results were published in Biomedicine and Pharmacotherapy last year. I would like to thank you for your attention. Here is my email, and if you have some questions, please keep in touch. Thank you very much.
Thank you very much, Professor Sforcin. Please could you close your sharing?
Thank you, Professor Sforcin. It was very interesting for us.
Yes. Professor Sforcin, I'd like to ask a question to you. The biological activity of propolis is generally attributed to phenolic substances, as we know. Therefore, I think you should give a phenolic restricted diet in the conditions of inclusion criteria in the study. What do you think about it?
Oh, this is a very interesting question. When we tried to start this, when I was invited to participate in this project, I said to myself, it's not good to make my extract. Then I talked to this enterprise to have standardized propolis capsules because they could say, we have a range of compounds, for example, phenolic compounds, to see how much they intake every time they take the pill. That's why we had a standardized protocol. And even finishing this research, some of the participants asked us if they could continue taking these pills during their treatment, because they did not stop their anti-retroviral treatment, but they included propolis in their treatments. So I think the phenolic compounds in these capsules should be in an appropriate concentration for their daily intake.
Certainly, you're right, but you know that coffee, tea, fruits has much more phenolic compounds. Therefore, volunteers can eat these foods and can affect the results, isn't it?
Yes, yes. But we tried to make a registration of their food habits in order to see if some of them could affect the results. As we could see, nothing changed before and after propolis intervention regarding these food habits. But it would be difficult to assess how much phenolic compounds were included in their diets and including propolis as well. But it's a very nice question. Yeah, very interesting.
Thank you very much, Professor.
Thank you. More questions?
It's one question in the chat. Your first name, Maurizio, is coming from region Italy in Veneto.
Yeah. In fact, I am an Italian citizen. I have the Italian citizenship, and my father and my mother came from Italy. Yes.
Perfect. Yes.
Grazie a voi. Piacere.
Okay, so I think we can move to the next presentation. But I think Nariman, we have his presentation to Efrain. And again, thank you very much again, Professor Sforcin, for your wonderful presentation.
Thank you. Thank you very much.
Thank you.
Thank you. Thank you. So the next presentation will be from Sandra from Nigeria, and her talk is entitled Cycloartan Major Beehive Protective Against in Southern Nigerian Propolis.
Okay.
So Sandra, are you here?
Yeah, I'm here.
Okay, yes.
Please start sharing your presentation and you can start.
Okay.
I think we have some problems with the connection. Sandra, are you on Wi-Fi? Okay, so Sandra, I'll share your PowerPoint from my computer, and then you can just say next. Okay.
Cycloattains, major
Yes.
Nigerian propolis.
Okay. So wait a bit. And you have some children in your home?
Can I share? Yes, let me share it. Host disabled participants screen sharing.
Yes. But tell somebody in your family to tell to the children to be calm.
Okay, thank you. Please take her outside.
Tell to go to some other room because it's a big noise. It's big noise.
Please take
Go
her
a bit.
outside, please. Okay, can I share my screen?
Okay, try again, but let's see. But it was difficult. It's better.
Disabled.
It's better, Sandra. I will share the screen for you, and we have no problems then.
Please take her outside, please.
Okay. You can start now, Sandra.
Okay.
Yes, we hear you.
Cycloattains major B high protective agents. Ongoing PhD PhD work under the supervision of Professor John Nigeria.
Sorry, Sandra, we cannot hear you.
Next slide.
No, it's we cannot hear you.
Please,
it is a problem with the communication. Yeah,
I can share the video. I can share the presentation myself.
Yes, but your voice, we cannot hear your voice correctly.
Okay.
Okay. One idea. Can stop the camera, stop the video. Maybe it will be, and I'll share your presentation. Yes,
okay.
And then you just say next. But are you on Wi-Fi probably? So okay, so let's try again.
Okay.
Okay, try now.
Okay. Yes. Okay, so next slide. Next slide.
Okay, this one too.
Okay. So propolis is a resinous glue used by bees for propolis production. And it has been used in traditional medicine since ancient times. And it's antimicrobial, antiviral, antioxidant, anti-inflammatory, anti-ulcer, immunostimulating, and anti-tumor properties has been reported. The botanical sources of propolis collection strongly depends on the specific geographical location and climate, because in different ecosystems, different plant exudates and secretions could serve as a source of propolis. Hence, there is a variation in chemical composition and is very complex, as over 500 compounds has been isolated. Next slide, please. Okay, so these the bees foraging plants of southwestern Nigeria and the infestation intensity. The first batch represents the plants where the bees forage most often with the highest visitation intensity. Some of the plants listed are Cola nitida, Magnifera indica, Coffee arabica, Cola acuminata, Cassipium annum, Z maize, Citrus sinensis, Dachina cola, and all of this. Other plants visited by bees, but not most often visited, include Taline triangulaire, Tricula africana. We have the Ananas commosus and others. Next slide, please.
Est-ce que vous entendez la présentation de Dr. Stéphane ou c'est un problème chez moi, la connexion?
No, it's I cannot hear also. So that's why I just I just put in the slides. Okay. And then at the end, we can ask her to make like a comment, like a synthesis. Can you hear me? Okay, let me check here. Yes, you hear me, yes. Okay, so Sandra, are you still with us? Okay. Okay, so
Sandra, are you still here with us? We can't hear you.
okay, so I propose, Nariman, that we go to the next speaker, and we chat with Sandra by WhatsApp or separately, and maybe we find a solution. Yes, because it's a pity not to hear her. What do you think?
Okay. Professor Sibel, please present our next speaker. I will send message to Sandra via WhatsApp in the meanwhile.
Of course. I'd like to introduce Efrain Alday. Presentation topic is phytochemical composition and bioactivity of propolis from arid and semi-arid regions of the Sonoran Desert in northwestern Mexico. Please.
Hi to everyone. Good afternoon. Thank you so much for organizing this meeting and also for providing the opportunity to present the results of our project. I'm going to share the presentation, and I would like to tell me if it is project. It can be observed.
Yes. Yes, it's perfect. Go
Okay.
on, Efrain. Perfect.
Thank you so much. My name is Efrain Alday, and I am from Universidad de Sonora in northwestern Mexico. And the talk that I'm going to present is called a Phytochemical Composition and Bioactivity of Propolis from Arid and Semi-arid regions of the Sonoran Desert, a project that has been headed by Carlos Velazquez, professor from Universidad de Sonora. Well, as we already know, propolis can be classified according to the phytochemical composition or constitution, and mainly it is reported that some of the most important sources or plant sources for honeybees can be classified according to distribution into temperate or tropical regions. For example, in temperate regions, the main botanical sources available for honeybees are poplar trees from Propolis species, as well as birch in some kind of different regions in Russia, or Mediterranean in the sense that plants from the Cupreaceae family are considered the main botanical sources. Well, a different scenario is obtained when propolis is produced in tropical regions. Example, in Cuba, the main botanical sources are Clusia species, for example, Clusia major or Clusia minor, or as well as we already heard early in this blog, I think, red propolis from Dalbergia castophyllum, or as well as Pacific propolis from Okinawa region, or etc., like Macaranga tenaris species. There is also a greenhouse, as we already hear from Professor Maurício Sforcin. It has its origin on Baccari in Draconpulifolia exudates. In that sense, it can be classified into these 7 enormous groups, but recent efforts have reported that in regions from arid or subtropical areas, such as in Africa or Arabia Peninsula, the botanical sources could be another one. This is important in the sense that the phytochemical of present in the different samples is definitely correlated to the biological potential of our samples. In that sense, that almost 20 years ago, the research group in which I work with has some different questions. In particular, for example, which are the main botanical sources or the chemical constituents of propolis that are obtained or collected from different areas, such as arid or semi-arid, as those one obtained in the Sonoran Desert, as well as which are the biological properties or the pharmacological potential of these samples. Sonora is located in northwestern Mexico. As we can observe in this map, this is the region. It is very much near to United States. And right now, for example, our time is like, we here are 7 a.m., practically 10 hours in less than the time of Romania. So we got a different and complete ecological variation according to other regions in Mexico, as well as in the North America. For example, Sonoran Desert is the most southern desert in the North American region, as well as the one that has the most different or biodiversity in that sense. Well, 3 different regions from the Sonoran Desert, Caborca, Ures, and Pueblo de Álamos, were taken into this project very much at the beginning. In that sense, phytochemical analysis revealed that the main chemical composition of our samples was comprised by phenolic acids, flavonoids, and as well as its esters. Importantly, chemical constituents that at this time practically are comprised into 30 of them, including flavonoids. Flavonoids are methoxylated derivatives and esterified flavonoids, including two different families of pinobanxine, as well as pinobanxine 3-alkanoates or pinobanxine 5-methyl ether, and as well as 3-alkanoids, as well as glycosylated flavonoids such as rutin or caffeic acid esters, as caffeic acid phenylethyl ester, which is very much popular for its bioactivity, and phenolic acids such as picumaric acid. Well, chemical constituents that apparently, at least in our Urease propolis, are maintained or preserved through all the year. In that sense, at least at the qualitatively point of view, we can observe a certain similarity. This is important because in our region, we can obtain propolis during the 4 seasons of the year. Interestingly, we can observe that so many of these compounds, I'm going to go back, are chemical markers of poplar type propolis. Particularly, for example, the family of pinobanxine alkanoates, as well as chrysine and galangine and pinosembrin are very much reporting to this kind of propolis samples. But it is interesting since we are in the desert. In that sense, other study specifically focused on Caborca propolis, which is a very much arid zone, revealed that the chemical constituents as well as poplar type markers are present, but they really have so many fluctuations in the concentration during the seasonal samples. In that sense, even if the qualitative point of view, the chromatographic profile is similar, quantitative variations are very much observed, which could induce different biological potential in our studies. In that sense, we extracted the samples, as well as we perform a collection of the surrounding plants, specifically by collecting the resinous material, extracting it from by direct and immersion extraction using methanol. And then the resinous material was concentrated and waxes were removed, and phytochemical analysis were performed in order to correlate the chemical composition of our propolis samples, as well as the exudates of the plant material that was collected. In that sense, we observed that the propolis from the region of Ures, which is a semi-arid zone, was correlated so in times, as well as by using the chemical markers, with Populus tremonti resins, confirming that our sample from the semi-arid region, in particular that one from Ures community, has its main botanical source in Populus tremonti resins, including those chemical markers. As well, we observed that particularly the exudates of Ambrosia ambrosioides, a plant from the Asteraceae family, has a particular chemical marker, which was campherol 3-methyl ether, which could be a source or additional source for this compound in our propolis sample. Well, this chemical composition, characterized by polyphenolic compounds, as well as a botanical source in Populus tremonti resins, provides to our samples from the Sonoran desert different biological activities that have been reported, including antioxidant, antibacterial, antiparasitic, antiproliferative, as well as immunomodulatory properties that were performed in human monocytes in collaboration with Dr. and Professor Maurício Sforcin. Well, to start with the free radical scavenging activity and antioxidant potential of our SP, we observed that the differences were obtained between the 3 samples from the different areas of the Sonoran desert, concluding that the propolis from the region of Caborca, the one that is collecting a very arid zone, was the most active in order to induce antioxidant potential by in vitro assays, specifically in a chemical assay such as DPPH, followed by UP and then propolis from Pueblo de Álamos. These UPM-PAP were the lesser in antioxidant potential in this assay. Therefore, since our Gaouar propolis induces the most antioxidant potential by this chemical assay, we perform a seasonal effect in order to correlate if those variations obtained during the different seasons of the year according to the quantitative variations between the popular type compounds. We observed that practically the samples from autumn, winter, and spring induce a very similar effect, even if a summer sample induced a lesser effect at the highest concentration, which was 100 micrograms per milliliter. In that sense, this assay did not yield a particular or very clear differences between the bioactivity of the seasonal samples. However, when we use another assay, which is a cellular antioxidant assay that uses this fluorescence probe, which is DCF, the redox state inside the site could be reported as induced, for example, with oxidative stress with hydrogen peroxide. When we treated particular these cells, which were M12, C3, F6, B cell lymphoma of murine model, we observed that differences between the seasonal samples were clearly reported. For example, autumn and spring samples induce the most potential antioxidative effect by protecting those cells to the oxidative stress induced by hydrogen peroxide. Obtaining that, autumn and spring were those that induce the cellular antioxidant activity at its highest point. Being, for example, summer and winter, those ones with the lesser effect. In that sense, this assay allows us to obtain information that was not clearly observed by using chemical assays in order to report the antioxidant activity. Therefore, our seasonal samples from the arid zone, such as Gaouar, can be obtained, for example, particularly in autumn and spring, in order to induce or produce a more biological protection against oxidative stress. With reference with antibacterial activity, practically our samples, induce the most potent effect against gram-positive bacteria, very much as it is known. Gram-negative bacteria were not sensitive to the action of our propolis samples in a very general way. And Uris propolis induced the most potent effect, having a MICs values under 200 micrograms per milliliter in comparison with Gaouar propolis and Pueblo de Álamos propolis, which were potent in some way, but not in the order of Uris propolis, specifically against Staphylococcus aureus, and also clinical strains that were obtained. Similar results were obtained in this sense. When we talk about the anti-parasitic activity of our sample, we use a Giardia lamblia parasite as a model in order to test the potential, specifically by evaluating the in vitro growth of Giardia lamblia trophozoites by using a trypan blue exclusion or staining, sorry. In that sense, Uris propolis again was the most potent sample of our tree from the Sonoran desert that induced the evident effect, having, for example, a IC50 values between 50 and 100 micrograms per milliliter in comparison with Gaouar propolis that did not induce any evident effect at those test concentrations. And interestingly, the seasonal effect was observed another time by evaluating different seasonal samples from Uris propolis against Giardia lambda trophozoites, observing that particularly the samples from summer and winter induce the most potent effect in this biological activity. And also, we are very much centered in the anti-proliferative potential of our Sonoran propolis samples. And particularly, we use so much this cellular model because of the sensitivity to propolis constituents or propolis extract, and also the evident morphological modifications that we can observe and also associate to a potential effect. In that sense, we demonstrated before that Sonoran propolis induces its anti-proliferative potential in different human and murine cancer cell lines by activating apoptosis cell death by using annexin V or annexin 5, sorry, and propionidide double staining in flow cytometry. We observed that Sonoran propolis induced apoptotic effect in cells from very early incubation times, and which was compared in some way with our control with caffeic acid phenethyl ester, also a constituent of our sample. We also observed a seasonal effect in Uris propolis in a different panel of cancer cell lines of human and murine cancer cell lines. And also when we compare this effect with the Propolis tremonti resins, the main botanical source, the differences were very much clear, particularly, for example, the sample of summer was the lesser active in Sonoran propolis, and also in the season of summer and winter from the Propolis tremonti resins. In addition, this bioactivity was lesser in our plant resinous material in comparison with propolis, suggesting that propolis is very much a complex mixture that is produced by honeybees, very much again, by including another resinous material from other plants that could improve the bioactivity more than even which is provided by the main botanical source, that Propolis tremonti resins. In that sense, also we observed that particularly morphological modifications were induced by Sonoran propolis, but not by Propolis tremonti resins, suggesting once again that the potential is higher in this sample of propolis in comparison with the main botanical source. For example, these morphological modifications that can be observed in photographs and are point very much with these plaque narrows, that are observed as elongated forms of our cell culture. For example, this is the morphology that is observed under the dissolvent treatment, which is very much the same as the untreated cells. But treating those cells with colchicine, which is an antimitotic drug that induces an evident arrest in mitosis by disrupting the polymerization and organization of microtubules, which are implicated in the formation of mitotic fuse, in order to appropriate the chromosome in mitosis, and then promote the cytokinesis. These forms are very much associated in some way to the mechanism of action of colchicine. In that sense, we observe similarities to our propolis treatment, which can be observed in C panel, but those morphological modifications are not observed with the treatment with the resinous material of Propolis tremonti. In that sense, we have that particular question in if the mechanism of action could be some way similar to that induced by colchicine in our propolis sample. Even if the morphological modifications are qualitatively similar, by using flow cytometry analysis and under the forward scatter and side scatter parameters, which could be discussed as the form or the size of cells, as well as in inner complexity. And by the quantitative point of view, we observe a very homogeneous cell population with these characteristics, even in colchicine and Sonoran propolis treatment, suggesting a similarity, at least in the morphological events associated to the anti-proliferative effect. And since colchicine induced this effect, as we mentioned before, we try to perform a cell cycle analysis in order to compare if those morphological events observed in our treated cells with Sonoran propolis are due in some way by a similar mechanism of action as that of colchicine that affects practically in metaphase, disrupting and affecting mitosis progression and then promoting cell death. As we observe by using propylene iodide assay in flow cytometry analysis, we observe that the untreated cells, and as well as those treated with dissolvent control, has this kind of normal distribution of cell phases, having the most of the cells is experiencing a G1 or G0 phase, followed by synthesis phase, and then G2M. No? But when we treated our cells, the M12C3F6 cells from B cell murine lymphoma, we observed that UP or from URES induced a 94.8% of the cells an arrest at G2M in a similar way as colchicine induced, concluding that the morphological observations or elongations that we obtain are very much attached to a particular arrest at G2M that could be induced specifically at mitosis phase. But since we did not observe these morphological modifications under the treatment with botanical source of our SP, which are Propolis tremonti resins, an opposite effect was observed. An arrest at G0, G1 was observed by the treatment with Propolis tremonti resins in comparison to that observed with SP and colchicine, suggesting that even if the chemical composition of our sample is mostly characterized by compounds that are provided by these Propolis tremonti resins, not necessarily those bioactive compounds that induce specifically anti-proliferative activity or antioxidant or even anti-parasitic or antibacterial could be obtained in a very much way from Propolis tremonti resins. In addition, Ambrosia confertiflora resins, which is another kind of Asteraceae plant, which is very much present in the region and is a shrub because its dimensions is very much short. This resinous material induced, I highlighted arrest at G2M phase, as well as those morphological modifications, suggesting the complementary addition of this resinous material in order to produce the Sonoran propolis, which has the particularities of a chemical composition for a poplar type, but not the biological potential of those samples that are characterized by flavonoids from poplar trees. In addition, we work with Professor Maurício Sforcin in a collaboration, and we found that our sample induced modulatory effects on the cytokine production by human monocytes, inducing an evident antioxidant potential even by comparing the treated cells, with those ones that did not receive any treatment, by decreasing the levels of in production of tumoral necrosis factor alpha, as well as by promoting an anti-inflammatory cytokine, which is interleukin-10. Therefore, several studies are needed in order to advance and characterize the effects of our sample in the immune system. Well, as concluding remarks, we can say that Sonoran propolis is a bioactive polyphenolic matrix, which is mainly derived from Propolis tremonti resins. In addition, Ambrosia confertiflora resins could be a secondary plant origin to our Sonoran propolis, according to pharmacological evidences, as well as other chemical studies or phytochemical analysis should be performed in order to confirm these results. A seasonal effect is clearly observed, and it influences the biological activities of Sonoran propolis throughout the year, as we have observed in our experiments or results. And also we consider that further studies are needed in order to advance in the molecular mechanisms that are underlying the pharmacological potential of our Sonoran propolis samples. And I really like to acknowledge our collaborators, which the project is headed by Professor Carlos Velazquez, in addition with Javier Hernandez, which was our beloved friend and also a very important person in the development of this project during all these years, as well as Humberto César Garcia and a Professor Luca Rastrelli from Università degli Studi di Salerno in Italia, and Professor Maurício Sforcin from Universidade Estadual Paulista in Brazil. And thank you so much for this meeting, and thank you for the opportunity for this talk. And I'm here for if you have some questions or comments, and thank you.
Thank you very much, Dr. Efrain. Your work is an important piece of a great propolis puzzle, you know, because we have to make these analysis for great puzzle. For this great puzzle, I want to talk about on botanical origin of propolis, because we know that pollen analysis is not sufficient to determine botanical origin of propolis, not like Hanina. It should be even be contamination, because we know that gymnosperms, voodoo plants, pollen is too much, and contamination is possible. Therefore, resin analysis and comparing with collected propolis is very important. It is my opinion. Thank you very much for your excellent work again. Thank you.
Thank you so much. Yes, indeed. No, the characterization is important in order to certify the product, as well as associate correctly the biological potential of the samples to particular molecules and also the plant species involved in the production. No? It is very interesting because propolis is not collected from trees as sometimes we could think about that. It is produced, it is regulated, it is a very complex material, and the proportions, for example, in our sample are very clear, even if the main botanical source is evident by the compounds and the chemical markers. The bioactivity is not necessarily linked to the plant as a sole one. It is most as a formulation, and I absolutely agree with you. Thank you, Professor Sibel.
Okay. I communicated with Sandra on the WhatsApp during the presentation of Efrain. Congratulations, Efrain.
Thank you so much.
Muy bien. Vamos a cooperar en México en futuro. Okay.
Muchas gracias. Esperemos que así sea, ¿no? Gracias.
Okay. Thank you again. Sandra, can you activate first your camera and then your microphone?
Yeah, Prof, I'm here.
Okay, very good. Your voice now is very clear, and
okay,
there is no noise. Okay, yeah. Let's try now to share your screen. Please try to share your screen.
Okay. Okay, thank you very much for the opportunity once again. My name is Sandra Ian from Nigeria. There's an ongoing PhD research under the supervision of Professor John Igoli, a known researcher on propolis from Nigeria. And my topic is cycloalteins, major beehive protective agent in southern Nigerian propolis. Of course, propolis is a resinous mixture produced by honeybees through mixing their saliva and beeswax with exudates gathered from tree or plant buds, sap flows, or other botanical sources. It has been used in traditional medicine since ancient times. It's antimicrobial, antiviral, antioxidant, anti-inflammatory, anti-ulcer, immunostimulating, and anti-tumor properties has been reported. The botanical sources of propolis collection strongly depends on the specific geographical location and climate, because in different ecosystems, different plant exudates and secretions could serve as a source of propolis. Hence, there's a variation in the chemical composition, as it is very complex substance with over 500 isolated compounds. So these are the bee foraging plants of southwestern Nigeria and their visitation intensity. These plants are being foraged by bees at different times of the year, and with their various visitation intensity. This plant listed the first one with the color colored in golden. We have plants from the plant source as Cola nitida, Magifera indica, Cora arabica, Cola acuminata, Cascium annuum, and others. We have the other ones that are also listed by bees, but with varying intensities. Of course, this list, they are not exhaustive. So these are also the bee foraging plants of southeastern Nigeria. And the bee plants, we have the Cajanus cajan, we have the Cascium annuum, we have the Citrullus lanatus, we have the Combretum paniculatum, we have the Lufa aegyptica, and for the bees, the bee trees, we have the Bellina grandifolia, Bombas noponzensis, we have the Citrus grandis, Citrus limon, we have the Erythrophilium guinensis, and we have the Manifera indica. So the relationship between these two vegetation types, they are all from the southern part of the country. And if you look at the foraging trees, they have similar bees and trees in common. I think that will also affect the chemical composition. So these are the images of bees and the trees found in southern Nigeria. Notably, we have the zimes, we have the Manihot esculenta, we have the Manifera indica, we have the cola trees, we have the raffia trees, we have the terminalia species, and others. So the objective of this study is to determine the major protective agents in southern Nigerian propolis and their antimicrobiological activities. So this is a map of Nigeria showing the propolis collection sites. Propolis in research in Nigeria is still new, and my supervisor is really working hard. We've been trying to do a lot of research on Nigerian propolis. So these are some of the collection sites in Nigeria. We have some places like Kaduna, we have Cross River, we have Enugu, we have Anambra, Bayelsa, Rivers, Abia, Ogun. Then the table shows the Nigeria propolis collection sites to date. Those samples colored in purple are the ones under the present study. We have the Ijabodo propolis from Ogun State, from the southwestern Nigeria. We have the Oka propolis from Anambra. We have the Anambra propolis. We have the Abia propolis. We have the Enugu propolis, all from southern parts of Nigeria. So these are some of the propolis samples, the pictures of Imo propolis. We have the Jabode propolis, we have the Enugu propolis, we have the Anambra propolis, and we have the Abia propolis. So about 6 propolis samples we are collected from southern Nigeria, and we are cut into small pieces, then pulverized. It was defatted, they were defatted with an N-hexane and extracted with ethyl acetate. And this extraction procedure was maceration. It was macerated for 24 hours, and the resulting mixture was filtered with a Wortmann filter paper, and the filtrate was concentrated with a rotary evaporator at 40 degrees Celsius, and the extracts were kept for further analysis. For this paper, the antimicrobial analysis of the Oka propolis will be fully discussed. So the crude extract was fractionated. The fractionation was done with 1 gram each of the extract, and it was achieved by column chromatography on the silica gel packed column eluted with hexane ethyl acetate in the ratio of 90:10 hexane ethyl acetate to 100% ethyl acetate. Several fractions were collected and were monitored using thin layer chromatography. Fractions with similar array values were pulled. Of course, we have fractions that were crystallized, and they were also collected. So the fractions, for the purpose of this study, fractions IPE 65, ABP 37, EP 50, 47, AMP 21, IJP 41, IAP 44 were all subjected to proton NMR in order to determine the compounds. So these are the results of the fractions that were subjected to the proton NMR. The first 4 sets, we have the Anambra Propolis fraction 21, and we have the Propolis, the IPE fraction 65. We have the Enugu Propolis, which is the EPE fraction 47, and we have the another Enugu Propolis fraction 50. And we have, I'm looking at this spectra, you see that there are very outstanding features. When you look at in the spectra, we have notable features like the methylene proton, olefinic proton that has 2 singlets at 4.71 and 4.66, and the alcohol region we have around 3.21 as the case may be. Then we have the cyclopropane ring, we have the methylene protons at 0.13 and 0.39. This spectra, this is the second set of the spectra. One interesting thing about these 2 spectra is that they look very outstanding and similar in terms of the nature of the compound they contain. And this was translated into their chemical shift values. So based on the spectra, the chemical shift values we are given below. Following the reference chemical shift by Ruiz Arakama et al. 2017, a typical cycloatenol has the olefinic methylene proton that gave 2 singlets at 4.72 and 4.66, the alcohol region 3.21, and the cyclopropane ring 0.39 and 0.15. And this chemical shift, we are inconsistent with the samples, these 5 samples, ABP 37, EP 47, IP 65, IJP 332, and IJP 41, telling us that the compounds could be cyclohexylenol. And based on the reference chemical shift, according to Ruiz Arakama et al. 2017, for 24-methylene cycloatenol, the fraction AMP 21, IAP 44, and IJP 28 also we are consistent with the reference chemical sheet for 24-methylene cycloatenol. So the compounds identified were cyclohexylenol and 24-methylene cycloatenol. The structures of the cycloatenol identified in the southern Nigerian propolis. Of course, from the analysis, we can see that cyclohexylenol and the 24-methylene cycloatenol were elucidated and identified in the southern Nigerian propolis. And these cycloatenes, from their biological antimicrobial activity, they were found to be a very good protective agent. So this table is for the antimicrobial activities of the crude extract and the isolated fraction of Orca propolis. We have 12. We use 12 microorganisms. We use about 5 bacteria, and the rest are the fungi. So the gram-positive bacteria are methicillin-resistant Staphylococcus aureus, the vancomycin-resistant enterococci, the Staphylococcus aureus, Streptococcus pyogenes, Escherichia coli, Klebsiella pneumonia, Proteus mirabilis. The last four are fungi, of which Candida albicans, Candida crusei, yeast, while the rest are mold. It's interesting to know that the ethyl acetate fractions gave standing inhibitory activity against the tested organisms. So that is why it is highlighted. They are highlighted. So we discussed that in the findings. And these are the minimum inhibitory concentration and the minimum bactericidal and fungicidal concentration of the crude extract of Oca propolis. So we are thinking, where are the bees getting these cycloalkanes? Why is it that the cycloalkane, the bees are making more of collecting more of the cycloalkanes? So that led us to the biosynthetic pathway leading to cycloalkanes. So, and using the squalene through enzymatic transformation, we got cycloalkanol, then leading to 24-methylene cycloalkanol and getting to cycloeucalinol. Then another question could it be that the enzyme stop this transformation? And I said, the question can also be answered by the vegetation type, the plant source, and the trees of the geographical location where the bees produce propolis. Southern Nigerian propolis has cycloalkane triterpenes as major constituents, as they are found in all of the 6 samples under study, though other compounds we identified but not part of this study. Cycloalkane triterpenes are ubiquitous in plant and tree sources such as Musa sapientum, Mammiifera indica, Manihot esculenta, Z. maize, Capiscum annum, etc., which are found in the southern region of Nigeria, whose vegetation type are rainforest, derived savanna ecosystem respectively, and are mostly visited by bees during foraging. This study was given by Ayashola and Davis 2012. From the animal spectra reported, cycloeucalinol and 24-methylene cycloalkanol were majorly constituents of the ethyl acetate fraction of the southern Nigerian propolis under study. The samples yielded other compounds apart from the cycloalkane triterpenes, such as flavonoids, lupiol, fumaric acid, and cycloalkane triterpenic acid. Apart from the Bonny propolis, which is from River State, which is red, Imo-propolis sample was also found to be red in color. So there's a relationship between the 2 locations in terms of plant source vegetation of the propolis samples. The 2 locations are all from southern Nigeria. Cycloalkane triterpenes identified has been reported to have anti-tumor, anti-inflammatory, anti-diabetic, plasmolytic, and cytotoxic properties. The results of the susceptibility studies reveal that all organisms we are inhibited by the extracts, except the Staphylococcus aureus and the Streptococcus pyogenes with 0 diameter zone of inhibition. This is in contrast with the work of Fox et al. 1993, whose study reported the most susceptible organism of propolis extract to be Streptococcus pyogenes and Proteus mirabilis. Bosio et al. 2000 reported the of propolis extract against Streptococcus pyogenes 6 strains tested by solution containing establish the susceptibility of E. coli and Staphylococcus aureus strains on propolis extract that were resistant to various antibiotics. Wally 2012 also established the antimicrobial activities of ethyl acetate extract and of propolis of Saudi Arabia and Egypt. And it was found that it inhibited antibiotic resistant E. coli and Staphylococcus aureus and Candida albicans in single and microbial studies. Staphylococcus aureus became more susceptible when it was cultured with E. coli or Candida albicans in single and polymicrobial cultures. The antimicrobial studies of the ethyl acetate crude extract and isolated fraction, that is the IPE44, gave the highest inhibition on organism tested when compared to other extracts. This was in agreement with the work of Dax et al. 2008, who reported that the antimicrobial activities of 6 samples of red propolis against Staphylococcus aureus, 4 of them demonstrated higher inhibition of bacterial growth with ethyl acetate fraction, which demonstrated the best activity. Future actions and recommendations. More profiling of propolis samples from other regions and apiaries in Nigeria should be carried out. And also biological studies on other southern Nigerian propolis extracts and bioactive compounds should be done. We're trying to identify more trees and plant sources of Nigerian propolis, and establishing a research collaboration on propolis with other scholars from various parts of the world will be highly appreciated. References. Thank you. Thank you very much for this opportunity to present my results. I'm happy to be a part of this API conference. Thank you. I will entertain comments and questions. Thank you very much.
Thank you very much, Sandra. Your results are very important for us. Also, your work is a piece of the big propolis puzzle. Thank you very much for your excellent results.
Thank you. Thank you very much, Prof.
Yes, very, very good, Sandra, again. And we must come to Nigeria to make their physical conference on antimicrobiology. What do you think?
That would be nice. That would be nice, Prof.
So you speak with all your professors, and then we come to your place, or we make one, like African propolis conference.
Okay, that would be great, Prof. That would be very interesting.
Okay, everything is possible. Okay, so Professor Nariman and Sibel, what do we go to the next presentation? Yes.
Venom session, I think so. Yes, session 5 on bee venom, and next presentation on antibacterial and anti-biofilm effect of bee venom from the east-west region of Algeria against multi-resistant gram-positive bacteria of hospital origin. Aissaoui Hadjira will present this presentation. Please, are you here?
Yes, I'm here. You hear me?
Yes.
Yes.
Activate your camera too, Hadjira, to see you.
You see me? You hear me?
No, we hear you, but we do not see you.
And what about now? You hear me? And you see me? You don't hear me? You don't?
You shouldn't share your presentation.
Oh, okay.
But you hear me, yes? Or
Yes,
not?
we hear you, Hadjira. If you cannot open your camera, I can present your presentation from my screen, and you just say next.
No, I can present.
You can? Okay.
Partage my yes.
But we cannot see you.
And what about now?
Not yet.
Is she co-host, Stefan?
She's co-host. I put her co-host. Yes.
Okay.
Oh yeah. Now it's coming. Your share screen.
And what about now? You.
Oh, okay. Now we see your screen. Can you make full screen?
Yes.
Click strong there. Yes.
Now, and what about now? You.
Still not full screen. But also we cannot see you. Do you have a camera? You have a laptop or a mobile?
Yes. I shut my camera, but I don't know what's the problem.
Okay. So then as I said, Hadjira, I stop the share screen, and I will present from my computer here your presentation. You just say next. It's no problem. Okay, so but you have an abstract here. Wow. So you do not send us the PowerPoint. Okay, so try again.
I don't.
Okay.
I don't.
Okay.
I will share with you the PowerPoint yet or not, because I don't see my presentation.
Yes, can you send me the PowerPoint, Hadjira? Send me the PowerPoint by email, and then send me quickly to my email address.
C'est bon, j'ai comment dire en anglais? J'ai envoyé le mail de my PowerPoint.
Mais, ok, attends un peu. Quand avez-vous transmis le PowerPoint? Parce que vous l'avez transmis à moi parce que je ne l'avais pas reçu.
Nariman, je pense Nariman.
Ah, ok, il serait bien de me transmettre à moi aussi, drstangassiou@gmail.com.
D'accord.
Vous avez...
Stefan,
or Nariman, Nariman, you are again co-host, so you can also open the PowerPoint from Hadjira. Okay, wait a second. Yes. Okay, let me do something more here. Now participants. Okay. Now, Nariman, can you hear me?
Sorry, Stefan.
Yes.
I can start to my presentation. Maybe.
Oh yes. Yes. Very good idea. Very good, Professor Sibel. And then I will speak in background. Yes. Start your presentation.
Okay,
yes.
I'm sharing.
Okay.
It's okay.
Yes, it's perfect. Go on.
Nice. Just a second. Yes. My second presentation topic is again on antifungal activity, but the products is different. Comparison of antifungal activity of royal jelly and epilernil. Royal jelly, we know that is a yellowish white, creamy, acidic secretion from the mandibular and hypopharyngeal glands of young worker bees of the Apis mellifera. All bee larvae, workers, and queens are fed with jelly for the first 3 days after hatching, and only the queen larvae continue to be fed with royal jelly throughout their development. During the first 3 days, nurse bees provide 2 different larval foods for queen and workers. The former is called the royal jelly and the latter is the worker jelly. Nurse bees provide a larger quantity and higher quality of food to the larvae in the queen cells, which causes the larvae to synthesize large amounts of juvenile hormone at 3 days old, thus leading to the development of the queen bee. Royal actin may be a specific factor in royal jelly to induce bee larvae to differentiate into queen. The queen can live for up to 5 years, while the workers usually live 2,500 eggs a day. Chemical structure of royal jelly, main component is water and its content water rate is highly high and 60 and 70%. Carbohydrates between 11 and 24%. Proteins between 9 and 18, and lipids for N8. We see vitamin, minerals, and others nutrition elements in royal jelly also. Sugars, fructose, and glucose, and saccharose. Major proteins of royal jelly constitute about between 80 and 90% of soluble royal jelly proteins. major royal jelly proteins. One is a weak acidic glycoprotein, which comprises about 48% of all proteins in royal jelly. The majority of lipids are royal jelly lipids, and more than depending. Sorry. Yes, depending on multiple factors, season, location, botanical origin, and among others, as effective or content of royal jelly. Antilipidemic activity, just a second, yes. Royal jelly has antilipidemic activity and effective in lipid metabolism also, reduce total cholesterol in the blood and increase HDL-C levels, HDL cholesterol levels by the inhibition of the absorption of cholesterol in the jejunum by the major royal jelly protein. Also, major royal jelly protein 1 block the reabsorption of bile acids. In the antioxidant activity of royal jelly, oxidative stress produced by the liberation of reactive oxygen species in the body is related to some pathological process. Its proteins and peptides are responsible for this activity. In hepatoprotective activity of royal jelly, it reduces oxidative stress, increase in hepatic antioxidant enzymes. In antiproliferative effect, 10-HDA differentiation and neurotrophic activity on murine neuronal cells. In neuroprotective effect of royal jelly, also we know that very strong antioxidant honeybee products royal jelly, and this activity responsible for reducing the lipid peroxidation and NO levels, restore the activity of antioxidant enzymes, decreasing TNF and IL-1 levels, reducing brain inflammation, anti-apoptotic activity by the down-regulation of BAX and caspase-3, and upregulation of BCL2 was found. Reducing the neural damage is other important factor. In anti-inflammatory activity, by the inhibition of NF-κB signaling through the FFAR4 receptor. Antimicrobial activity of royal jelly is very important, and antimicrobial peptides of royal jelly had antimicrobial activities against yeast, gram-positive and gram-negative bacteria. Royalizine is a potent antimicrobial peptide, isolated and purified from the royal jelly of Asian honeybee Apis cerana serrana by fusing with glutathione S transferase in Escherichia coli, could inhibit gram-positive bacteria, Bacillus subtilis, Micrococcus flavus, and Staphylococcus aureus. Also, 10-HDA is also highly effective against animal or human-specific pathogens, including Staphylococcus aureus, Staphylococcus intermedius, Staphylococcus xyloxus, Streptococcus alactolyticus, Salmonella chloriosus, Vibrio parahemolyticus, and Escherichia coli. In the literature, tested microorganisms are Candida albicans, Candida glabrata, Candida tropicalis, Penibacillus larvae, Vibrio parahemolyticus, Enterobacter cloaca, Escherichia coli, and others. And apillarnil, drone larvae. Apillarnil is obtained through homogenization, filtration, and lyophilization of the drone larvae at the early stage of development, showing a milky consistency, yellowish gray color, and a bitter taste.
It contains proteins, carbohydrates, lipids, B complex vitamins, biotin, folic acid, inositol, choline, and a high content of micronutrients and macro elements like potassium, magnesium, phosphor, and others. Compared to royal jelly, apilernil contains a greater amount of free amino acids. Apilernil is rich in steroid hormones such as testosterone, progesterone, estradiol, prolactin, including A-DEC2-N-dioic acid, which is similar to the estrogenic fatty acid isolated from royal jelly. We can use apilernil especially in estrogen deficiency. Maybe it is an idea. I couldn't find any literature on this topic, but we think that it can be. Stimulated sexual maturation on male broilers at an early age. Increased the weight of seminal glands and epididymis, the ejaculated volume, the density of germ cells, and sperm mobility in pigs. We found that several literature on this topic. Apilernil also reduced the high levels of pro-inflammatory cytokines induced by sepsis in adult male rats, reduced the number of degenerated neurons, and exerted a neuroprotective effect preventing apoptosis. In complementary medicine, to treat a variety of diseases and health conditions, including ovarian dysfunction and male infertility, thyroid and immune disorders, and malnutrition in children, also we can use apilernil in andropause problems. In this study, yeast strains were isolated in the RGS University Medical Faculty Hospital, Department of Medical Microbiology, Mycology Laboratory, a total number of 84 strains which isolated from various clinical samples in the study. A total of 84 candida SBP strains were isolated from 57 blood cultures, 17 bronchoalveolar lavage, 5 sputum, 3 urine, 1 intra-abdominal fluid, and 1 tissue sample. Identification of the strain. Yes, identification of strains was done by both conventional and molecular methods. Candida albicans ATCC 90028 was used as a positive control strain. Phenotypic and identification of the strains was performed according to microscopic morphologies, colony colors in the chromogenic medium. Urease activities and elevation results of the carbohydrate assimilation test with the EPI-20C EUX. Molecular identification of strains was determined by sequence analysis. The gene region was amplified by using ITC1 for primer and ITC for reverse primer. Sequence PCR was performed by using the big dye terminator cycle sequencing kit. DNA sequence analysis was performed through the ABI-PRES 3100 genetic analyzer device. In vitro antifungal susceptibility testing was performed according to the recommendations proposed by the Clinical and Laboratory Standards Institute. Water and ethanol extracts of fresh and be bread. It is wrong. Royal jelly, and it is from our other research. Royal jelly and apilernil were tested by the broad microdeletion test. Candida albicans were used again as quality control test. RPMI medium with L-glutamine without sodium bicarbonate and phenol red used in this study. For the extraction of royal jelly and apilernil samples, ultrasound-assisted extraction was applied. Lyophilized and fresh samples were weighed as exactly 30 grams in a glass bottles, and extraction solvents were incorporated into the samples, and the bottles were covered tightly to prevent the solvent leakage. At the end, the extraction was started in an ultrasonic water bath at a constant temperature for 30 minutes at 37 kilohertz frequency. Samples exposed to extraction by using a ultrasonic process at constant temperature 50 centigrade degree. After extraction process, the bottles were removed from the bath and waited for a time to cool down. At the end, the samples were filtered using filter paper and liquid extracts were obtained and kept in glass tubes for further antifungal analysis. It was prepared to have a final concentration of 0.6 milligram per milliliter for antifungal analysis. MIC mean, in other words, GM, geometric mean of the ethanol extract of lyophilized royal jelly was higher than the water extract against Candida albicans you see on the table. However, the antifungal activity of both extracts of lyophilized royal jelly was higher than that of fresh royal jelly. When two extracts of fresh royal jelly were compared, the MIC value of the water extract was lower. The activity of the ethanol extract of lyophilized against Candida albicans was higher than that of royal jelly and all extracts of epilernal. In fact, the ethanol extract of lyophilized epilernal was as effective as the positive control fluconazole. As in royal jelly, MIC values of lyophilized epilernal were higher than fresh ones, while fresh epilernal water extract had higher activity than ethanol extract. Of all the extracts tested against Candida albicans, the MIC value of lyophilized epilernal was the lowest. This value was 8 times lower than the ethanol extract of the royal nearest lyophilized royal jelly. In the antifungal activity test against Candida paraphysiolosis, just a second, yes, ethanol extract of lyophilized royal jelly had lower GM than water extract and both extracts of royal jelly. The GM value of the water extract of lyophilized royal jelly had a lower GM value than the fresh royal jelly extracts. Among the fresh royal jelly extracts, the water extract had a lower GM value, although the GM value of lyophilized epilernal and fresh epilernal was close to the GM value of the ethanol extract of lyophilized royal jelly. It was considerably lower than the ethanol extracts of epilernal. The GM values of ethanol extract of lyophilized royal jelly and water extracts of lyophilized and fresh epilernal were close to each other and lower than all other extracts. It was approximately 2 times that of fluconazole used as a positive control. The most effective extract against Candida tropicalis was the water extract of lyophilized royal jelly, and the water extract of lyophilized epilernal were close to each other. The GM value of the extracts of both products was higher than the positive controls, fluconazole and caspofungin. Against Saprochet capitata, GM values of ethanol and water extracts of lyophilized royal jelly and epilernal ethanol extract were found to be close to each other. These values were higher than fluconazole used as a positive control, but lower than caspofungin. It is other control agent, you know. And in the efficacy test against Candida inconspicua, while the GM values of lyophilized royal jelly and epilernal were the same, the GM value of the fresh epilernal water extract was close to these values, while these values were 2 and 3 times higher than fluconazole. They were higher than the GM value of caspofungin. GM values of the other extracts were also found to be high. So here, just a second. In this test, Candida, in the efficacy test, Candida glabrata, efficacy test against Candida glabrata, GM values of ethanol extract of epinarnyl and water extract of fresh epinarnyl were lower than the other extracts, while the GM values of the ethanol extracts of lyophilized royal jelly were close to these. These GM values of the extracts were 2 and 3 times that of the positive control fluconazole. For Candida krusei, GM value of lyophilized royal jelly was lower than other extracts. However, all extracts of both lyophilized and fresh epinarnyl were close to this value. As a result, in our study, of all the extracts tested against Candida albicans, the MIC value of lyophilized epinarnyl was the lowest. Interestingly, the activity of the ethanol extract of lyophilized epinarnyl was as effective as the positive control fluconazole. We know that fluconazole is traditional drug for curing the antifungal diseases. Furthermore, this value was 8 times lower than the ethanol extract of the nearest lyophilized royal jelly. Against Candida parapsilosis, the GM values of ethanol extract of lyophilized royal jelly and water extracts of both lyophilized and fresh epinarnyl were close to each other and lower than all other extracts. It was approximately 2 times that of fluconazole used as positive control. The most effective extract against Candida tropicalis was the water extract of fresh royal jelly and had the lowest GM value. The GM value of the ethanol extract of lyophilized royal jelly and the water extract of lyophilized epinarnyl were close to each other. The GM value of the extracts of both products was higher than the positive control fluconazole and capsofungin. Against Saprochetta capitata, GM values of ethanol and water extracts of lyophilized royal jelly and lyophilized epinarnyl ethanol extracts were found to be close to each other. These values were higher than fluconazole used as positive control, but lower than capsofungin. In the efficacy test against Candida inconspicua, while the GM values of lyophilized royal jelly and epinarnyl were the same, the GM value of fresh epinarnyl, water extract of fresh epinarnyl was close to these values, while these values were 2 and 3 times higher than fluconazole used as a positive control. They were higher than the GM value of caspofungin. And in discussion session of our research, antimicrobial activity of royal jelly has been demonstrated in studies carried out to date. In this study, its effectiveness was tested on different yeasts. Studies on the antifungal activity of epinarnyl are scarce. In the study, it is an important result that lyophilized epinarnyl was as effective as the positive control fluconazole, and antifungal activity was higher than royal jelly, especially against Candida albicans. Thank you very much. Thank you for your attention.
Very good, Professor Sibel Silici. As always, you are very, very good. You can reactivate your camera. It was a bit of broken sound.
There is a problem, I think so. Now it's okay.
No, it should be okay. Yes, thank you very much.
Yes.
And it was very interesting. You worked with apilarnyl, also with lyophilized apilarnyl. And there are not so many companies or laboratories who are working with this kind of product, let's say. Yes, very, very good. Okay. We have Hadjira. I have the PowerPoint. Hadjira, can you activate maybe now your camera? Let's see if we can.
Yes, I'm here. You hear me and you see me?
We hear you, but we do not see you. No problem.
I don't know the problem, but
okay, no problem. You can send us your nice photo, and then we'll share in the WhatsApp group afterward.
Thank you. Yes.
So I'll present you. I'll share the screen for your presentation, and then you can comment each slide and say next, and so on. Yeah. Let me know if you can see the screen now. Can you see the screen? And
yes,
can you see if you can see the full screen? Yes.
Yes.
Okay, please start.
So firstly, you hear me? Yes, you hear me?
Yes, we hear you. Yes, you can start presenting.
Thank you.
From the screen.
Firstly, thank you for accepting my participants and to give me the chance to be with you in this first international conference on microbiology. So I'm a doctorate in microbiology affiliated with the Laboratory of Applied Microbiology in Fraud, Biomedical and Environment in the University of Tlemcen in Algeria. I will tell you about antibacterial and anti-biofilm effects of bee venom from the east-west region of Algeria against multi-resistant gram-positive bacteria of hospital origin. Next, please. This is my plan. I will start by a small introduction, general information of all bee and bee venom and material method, results and discussion. I will finish by a small conclusion. Next, please. So over the last decade, microbiologists and infection diseases specialists have experienced a radical change in the way to face infection. The classical acutely evolving and antibiotic treatable infection disease that have caused the millions of deaths. This is the mild of the late century. For example, diphtheria and cholera have positively led the skin to infection characterized by chronic development. That's often alternate with phase and of acute extravasation refractory to antibacterial treatment, and displaying undefined pathogenic mechanisms. Will the classical acutely every infection are thought to evolve independent free-floating planktonic microbial cell. Examples is in vitro and in vivo studies have proved to the notion that mean types of chronic infection are standing by seasonal microbial aggregate now as a biofilm. So the World Health Organization identified antibiotic resistant bacteria as one of the greatest threats to human health in the future. There is an urgent need to novel antimicrobial agents account in the fair extended target. It's for that the failure of the traditional antibiotic to control infection lead to the search for alternative agents with a new mechanism of action, and the product of natural origin can often diversity of active principle and mechanisms action will many cells are now stimulating their research on the world planet. Next, please. Now let me represent for you the bee. So the bee is an insect that belongs to the entomological order of Hymenoptera and the family Apidae, and the genus is Api. Next, please. The mellifera bee of the genus Api is described over the world in the exception of found as Asia, the ordered 3 species of a bee. Next, please. So the bee is considered like a small factory because it's responsible to produce for what's called the heavy products, for example, honey, bee venom, wax, pollen, and propolis, all jelly, etc. Next, please. Now we move to the venom. So the bee venom or apitoxin is secreted by a gland located in the abdominal cavity of a bee. It is odorless and inodorous and transparent acidic liquid that bee after use as a defense tool against predator. Commercially now as apitox or apitoxin. As reported by many publications, bee venom contain several activity molecules such as peptide and enzymes, including melittin is the major one, and apamine, adolapine, phospholipase A2, histamine, adolapine, etc. The main constituents are melittin, which account for about 50% of dry venom and 12% for PLA2. Next, please. The pharmacological of bee venom has been studied throughout in vivo and in vitro, like you see in the photo. That he represents so effects like an anti-mutagenic, antimicrobial, anti-inflammatory, antioxidant, anti-metastasis, anti-tumor, and anti-treat. And he has a radioprotective also. Next, please. Now we put the second party that represent the material and method. So for testing the antibacterial and anti-biofilm activity of the bee venom, we selected the strain of clinical origin from medical diseases. That then we identified them by VTEC. And then testing them whether there are biofilm formation or not by the tissue core method, which allows quantitative assessment of biofilm formation in this strand. Next, please. Yes. Now, what about bee venom extraction? So an electric bee venom collecting technique was described for the first time in 1954, by microbiology Conference, and this collector have been used under different conditions. So voltage from 24 to 13 voltage, and the pulsation duration is to 2 to 3 seconds, and pulse frequently from 50 to 100 hertz. Next, please. Passing now to be venom activity using the broad microdeletion method. Firstly, after addition the bacterial inoculum and occluding in the microplaque 96 well, with adding the bee venom at different concentration and incubation for 24 hours at 37 in temperature, like you see in the photo. And constantly for the the antibacterial test, the addition of bee venom at different concentration is put in place after the formation of biofilm, following the same previous technique that incubated also for 24 hours at 37 interpreter. After that the optical density measured by spectrophotometry, like you see in the photo. Next, please. So for now pass to the third party to my presentation, the results and the discussion. So for the results of physics identification, so that the strain are all gram positive, mean the Staphylococcus aureus, methicillin resistance, and Enterococcus faecalis. All these strain are pathogenic and multi-resistant and the strong formation, biofilm formation. Pass now to the results and antibacterial activity. Yeah. So our products has a higher activity that the minimal inhibitory concentration rate to 11 to 23 microgram in a milliliter. Our results are according. Next, please. Our results are according to previous studies such as kind and all in 2020 and Melis in 2021 and about Nerder in 2021 that the minimal inhibition concentration be varied to 3 past 7 to 20 and so and for the anti-biofilm activity, the bee venom can inhibit the biofilm formation with the sub minimal inhibition. No, yes. So this result is very interesting to. I'm sorry. And for the anti-biofilm activity, the bee venom and can inhibit the biofilm formation with the sub minimal inhibitory continuity, like you see in the histogram for the both of bacteria. So in the Staphylococcus aureus or Enterococcus faecalis. So this result is very interesting to develop as reported by many publications that the cytolytic activity of the melittin and the PLP2 are responsible for this effect by inducing pore in the membrane cell. Next, please. So in this study, bee venom was found to inhibit the growth and survival of a specific bacterial strain. Also, bee venom may be an effective complementary antibacterial agent for use against specific pathogenic bacteria. Moreover, the research on bee venom may lead to the future design of novel pharmacological. Next, please. So for conclusion, I can see that therefore we suggest that bee venom can be used as a natural anti-biofilm, antimicrobial agents. The survey aims to promote the use of natural products in particularly bee venoms in Algeria to find alternative solution to reduce and inhibit the addition of microorganisms to medical device and consequently to reduce the application of biofilm and infection related to medical plants. Next, please. Thank you for your attention. And this is a photo for my city Tlemcen in Algeria. Thanks. Thank you.
Thank you very much, Hadjira, for your nice presentation on bee venom.
Thank you.
Have you got any question? Sorry, any question from participants? I think no questions. Again, thank you, Hadjira.
Thank you.
Stefan?
Oh,
Yeah.
yes. Yes, well, it was a very good presentation, very clear. And what is fascinating is that, like in many other indications, so we see that several bee products have the same kind of effects. Like honey is anti-biofilm, propolis is anti-biofilm. We see now that also Venom is anti-biofilm. And I'm thinking maybe to a $1 million product, like Hadjira was saying, to make a kind of mixture, a cocktail, which has honey, propolis extract, some bee venom, some royal jelly, and then to analyze it and to use it against biofilm formation. What do you think about this idea? First, let's ask Hadjira because she was the previous speaker.
Yes,
Hadjira,
it is a good idea to meet a mixture for all the products of bee for the bee. So propolis, venom, and pollen. We can prove a solution for this problem, like a biofilm.
Yes. Probably we'll need in the practice, in the clinical, we need to make first antibiograms with several propolis extracts, with several honeys, several maybe even different venoms. And then we see what is it's working really very good. And then we make the preparation. Yeah. So normally each hospital should have a laboratory, apitherapy laboratory, or some kind of very fast or communication, or like in China, they have these shops with hundreds of medicinal plants. Maybe we can have like a place with hundreds of different bee products, extracts, and so on. And then some very fast delivery. And then the expert says, we need this combination, this cocktail, this mixture. And then we send by drones quickly to the hospitals.
Yeah.
Yeah. Okay. So you agree also with this idea, Hadjira?
Thank you, sir. Thank you, Professor.
Okay. Professor Sibel, what do you think about this idea? How to do it in practice to make the cocktails? What would be the rules to make the mixture? How to give them to the patients? And also, Prof. Narimani, what do you think, and the other colleagues?
Actually, it is very difficult, Stefan, because you know that propolis and other honeybee products are a mixture, different phenolic substances, terpenoids, and other important compounds. Therefore, again, other mixed products is a very, very big problem, you know. But I think that it will be very effective on microorganism, I'm sure.
Yes, it's a big problem for the scientist.
Yes,
because
yes,
he or she cannot explain what component is working. But for the clinician, for the therapist, and for the patient, he wants to be healed. Yes. So we cannot do the standardization according to the composition, the substance, but if we go to the standardization according to the pharmacological property or the property, and we see, yes, and we see with the antibiogram that it's working, why not?
Yes, of course.
What do you think, Narimani? Professor Narimani?
It's a good idea, but I think we need to first have a first step, which is try to understand the mechanism of action of each bee product, and at least correlate it with the maybe the most important compounds we are thinking they are responsible for this pharmacological activity. This will be the first step. The second step is to find the good mixture, because maybe when we use half and half, it will be good. When we use half and maybe un quart, it will be not the same thing. So first, understand that the mechanism, find the main product responsible of the activity, and I think find the good mixture with the different ratio will be the second step, and then we can try on in vitro and maybe after in vivo.
Okay, very good, very good. Related to this kind of combinations, to tell you the truth, we are doing already this in Romania for very severe infections like infected wounds, and we'll discuss more tomorrow. We have already a preparation which has a good antibacterial honey. We have in Romania honeydew honey. Then we put propolis extract, like normal extract, alcoholic extract, but we evaporate the alcohol. Then we have very concentrated propolis extract. And then we add also thyme oil, very small amount of thyme oil, because thyme oil is very, very powerful antibacterial. So it's an API aromatherapy combination. And this is extremely powerful as antibacterial. It's more powerful than honey alone or propolis alone or essential oils alone. And tomorrow we'll show about this kind of preparation, and we can give you the $1 million idea on how to do it. Yes, okay. Yes.
Essential oil are very interesting because they are very effective and they are used in very, very small amounts. So mixing essential oil with other products, even if it's a plant or a bee product, will be a very interesting approach. They are very small, the mechanism is very well known, and when we will mix, we will get a lot of activity with very, very small amounts. I mean, we will have la relation structure chimique activité et aussi la relation concentration activité serait vraiment optimale.
Yes, so the relationship between the structure, the composition, and the property will be evaluated, and then it will be put into practice. So it was the last words, but probably Prof. Narimani. Oh yeah, maybe you have some. Yeah, no, you can unmute. Let me check. Yes, okay. Now you can unmute. Yes, yes.
Sorry, I lost my connection few seconds.
No problem, no problem.
So I totally agree with you about bee product and their mixture with the essential oil.
Okay, very, very good. Okay, so we have here, I saw among us is Maria Cristina Marcucci from Brazil, and now she's residing in Italy. Yes, Maria, hello, pleased to see you. Okay, please activate your microphone, and also put the, okay, so put the put the camera a bit low to see you better. Yes, like this.
Is it good?
Yeah, now it's very, very good.
Hello, Dr. Stefan Stangatiu. Hello, everybody.
Yes, and
hello.
Yes, Maria.
Can you hear me?
Yes, yes, we can hear you.
Okay.
I would like to introduce Maria Cristina shortly. Maria Cristina is one of the pioneers of the research on propolis in Brazil. She has a lot of studies, a lot of published articles. She has a huge experience in this topic.
Thank you.
And she knows very well not only propolis, but many other bee products from Brazil and from all over the world. And that is why we kindly asked Maria Cristina to make the last presentation today, which will be like kind of a synthesis of all the properties of bee products, the study she done in Brazil. So, Maria Cristina, can you share the screen?
Could you share for me, Dr. Stangatiu?
Okay.
If you have the PPT presentation, is better for me.
Yes, yes. Okay, so I'll share.
Thank you so much.
Okay, wait a second, and I'll share for you. Yes. Yes, okay. And then you just you comment the slides and you say next, next, next.
Okay, great.
Okay.
Thank you very much.
Okay, so yes. So you can start. Please start.
Okay.
So you see the screen?
Now?
You see my screen?
No, no.
Oh, why don't you see my screen? Oh, yes. I know why you don't see my screen, because I didn't do share screen. Okay. Now you can see it?
Okay, good, very good.
Yes, okay. Yes, please start.
Okay, thank you. Hello, everybody. Good evening. I'm so happy to stay here in this conference. And I would thank you to Dr. Stefan Stangaciu, because I know him for a long time. He is a very nice person. He is working on apitherapy for a long time. And he invited me to speak about antimicrobial activity of Brazilian bee products. The next, please. I am Maria Cristina Marcucci. I am a collaborating researcher in the Department of Biosciences and Oral Diagnosis from a public university in São Paulo, Unesp, in São José dos Campos City, in Brazil. The next, please. Here, only a summary of my curriculum. If you want, you can see my ORCID. I have a lot of publications, as Dr. Stangaciu said, and I am in the ABNT Commission for Regulations, Brazilian Commission in Regulations of Bee Products in Brazil, and now I am, since 2020, I am in the ISO Committee for Standards on Propolis, Honey, and Pollen, and you can go to the next, please. Yes. Bee products in Brazil have a great importance because our biodiversity allows us to produce excellent products without disease, for example, bee disease. The next, please. Next. Yes. Several therapeutical actions are attributed to bee propolis. I think that it's normal to everybody to listen and to see this slide, because we have a long time living and studying bee products. The next, please. There are many benefits of bee products to human. Everybody knows. If for this society so well organized and maintained over time, this is my question. Its products are good for this society, how could they not good for humans? That's the question. The next, please. In the modern world, many of these products, such as bee venom, bee pollen, honey, royal jelly, and propolis are used, especially in traditional medicine. The next, please. These apitherapics are effective against a number of diseases, from arthritis and chronic pain to multiple sclerosis and cancer, as well as inflammatory and degenerative diseases. Many scientific reports confirm their effectiveness. The next, please. I was looking for a lot of articles. Maybe 2 or 3 weeks ago, if you remember, Dr. Stefan, I sent for you a lot of publications about Brazilian bee products against many diseases and the antibacterial activity. The next. Today, thousands of healthcare professionals practice apitherapy around the world. In Brazil, the situation is not so good, because some professionals from health doesn't believe in the efficacy of the apitherapy products. The next. This is an important publication about Senel and Demir, and they did a review made a review about the complementary medicine on apitherapy since 1980 and 2016. The next, please. About the research on apitherapy all over the world. And we have United States, Brazil, and China, the most important countries that they investigate the literature to do this review. The next, please. And I'm here, one of the most important researchers publishing reports about bee products such as Propolis, the most important bee product that I have working for a long time, more than 25 years. The next, please. And the team of bioactivity of Brazilian bee products, and we can see now the results. Please, the next. The most important products with antimicrobial activities are honey, propolis, and pollen, because I focus in these three bee products, because in Brazil, the research is main in this field, honey, propolis, and pollen. I think that there are other publications about other bee products too, but there are few. The next, please. Let me start about to discuss of properties of honey. Everybody knows that honey is a product produced by bees from nectar. The next, please. Bacterial activity was reported against Salmonella, E. coli, Shigella, and the Vibrio cholera. The next, please. And for example, in this publication, a new recent publication in Brazil, 10 honey samples were collected in the state of Bahia, and they evaluate the antibacterial activity of 10 kinds of different samples of honey against the E. coli, Pseudomonas aeruginosa, and Staphylococcus aureus. And the authors verified that in all samples, they had significant antibacterial activity, and the relationship between color and antimicrobial activity against Staphylococcus aureus. For me, it's a surprise, but I have results about the antioxidant activity of different kinds of Brazilian honeys, and the content of minerals, for example, and the color, of course. The next. Yes, this article was published in Portuguese. The next, please. And here we have another publication about antibacterial and antioxidant activity of honeys from south in Brazil. Rio Grande do Sul is a region in the south of Brazil. They studied the two gram-negative microorganisms, Shigella dysentery, Salmonella typhimurium, and 2 gram-positives, Staphylococcus aureus and Bacillus cereus. The next, please. Please, yes. The antibacterial activity of 24 samples, honey samples from the state of Rio Grande do Sul was evaluated. All samples showed the antibacterial activity. The next, please. The next. And the sample H4, 5, and 8023 showed the best results. 10 milligrams per milliliter from pathogenic bacteria. It's not a best activity, but in my opinion, it's a very, very good activity, because in clinical studies, we have efficacy of honey. The next, please. The other. And they found a positive correlation between carotenoids and phenolic compounds, and they conclude that these compounds have antibacterial activity. The next, please. And this is another publication, not from Brazilian honey, but only to show to everybody that propolis honey has activity against Helicobacter pylori. They use the Greek oregano honey against clinical isolates of Helicobacter pylori. It's a very interesting work, and they conclude that all clinical isolates was susceptible to honey. The next, please. And these microorganisms, such other reports, E. coli, Proteus species Pseudomonas aeruginosa, Salmonella, Staphylococcus aureus, Streptococcus, Candida albicans, and tropicalis. This is a report from Professor Peter Molan. The next, please. And he concluded that Manuka honey has a very interesting activity against these microorganisms. The next, please. And this is a very important publication, in my opinion, because it is a report published in Wound Medicine about the efficacy of honey in wound healing. It's very, very important, because I think that Dr. Stefan Sangaciu knows a lot of these results about wound healing using honey. The next, please. We are now speaking about pollen. Bee pollen is a mixture of nectar and the pollen from plants, and there are many amino acids inside, and vitamins, proteins, and amino acids, and minerals, and so on. The next, please. Carbohydrates, enzymes, nucleic acids, vitamins, and the pollen has antibacterial activity too. The next, please. Pollen has the ability to regulate the intestines, destroying dangerous microorganisms. And the researchers observed the activity of pollen against, especially against E. coli. The next, please. The next. Like honey, pollen has antimicrobial activities, properties. The next, please. This is a report of my research group, me and Dr. Alexandra Savaya and colleagues from China. I sent this report to the Dr. Sangaciu. It's a very, very interesting article, a review article about different properties of pollen, including antibacterial activity. The next, please. And in this report, we found articles, many articles about antimicrobial activity of pollen, bee pollen, against bacteria, gram-positive and gram-negative. The next, please. And against fungi, for example, Candida and the other kinds of fungi. The next, please. And this is a Brazilian article published in Journal of Apiculture Research about phenolic content, antioxidant properties, and antimicrobial activity of Brazilian bee pollen. The next, please. And the authors conclude that bee pollen efficiently inhibit the growth of all microorganisms studied, such as Candida albicans, the most resistant, but Staphylococcus epidermidis was the most sensitive. The next, please. Let me speak about propolis because I love so much to speak about propolis. And propolis, what is it? The next, please. The propolis is different from honey. Honey, bees collect nectar to produce honey, and the bees collect resin to produce propolis. The next, please. Is a mixture of chemical substances with a characteristic aroma and viscous consistency. The next, please. And bees collect this resinous material from tree buds or other parts in plants. Yes, this is the typical green propolis. The next, please. And from exudates and buds. And the propolis has numerous biological and pharmacological properties. You can see here a bee collecting propolis in Baccharis dracunculifolia. The next, please. The collection is carried out by specialized bees. We can see around in red, a circle in red, bees with resin from Baccharis dracunculifolia, up and down a hive with a lot of green propolis. The next, please. The bees collected on buds, exudates, and leaves. Here we can see bees on Baccharis dracunculifolia, the first, in down bees collecting resin from plants in north of Brazil to elaborate red propolis. The next, please. And here there is a picture of bees collecting resin in Baccharis dracunculifolia. The next, please. And after collection, the resin is transported to the beehive and used by bees. The next, please. And they use to seal the entrance, keep the parts together, using combs and kill and cover invaders inside, such as very good, a small mouse that they killed this small animal and cover with propolis because it's big, and for the bees it's impossible to put outside this picture, a friend of mine in Brazil sent me this picture, and it's very interesting. The next, please. Prevents contamination by pathological agents. The next, please. And everybody knows that propolis is the hive defender. The next, please. The color is different, of course. In Europe, we can find dark yellow to dark brown, but in Brazil, we have yellowish brown, greenish brown, and red. The next, please. We can see here different colors of propolis: brown, green, yellow, brown, and red. The next, please. The same. The next, please. And now I'm speaking about Brazilian green propolis. The vegetal source is Baccharis dracunculifolia. It's a plant, typical plant from Brazil. The name is Alecrim do Campo, the common name. The next, please. And here is the same picture. Bees in green and brown propolis. The next. The source of resins that bees produce red propolis in Brazil are Dalbergia ecastaphyllum and Symphonia globulifera. These two plants produce red resin, and the bees love these plants, yes, to elaborate this kind of propolis, red propolis. The next, please. And here is the Brazilian typification of propolis. In the north, we have in Bahia and the other places, we have normally red propolis. Green propolis from Baccharis is from Minas Gerais, São Paulo, and the north of Paraná. And in the south of Brazil, we have BRG, another kind of propolis. The main compounds are coniferaldehyde, vanillin, and other kinds of compounds different from green propolis. In green propolis, we have a lot of acids, cinnamic acid derivatives, caffeic acid, and a few flavonoids. But in north of Brazil, we have propolis with a very significant amount of isoflavones and flavonoids. The next, please. Green propolis has antimicrobial and antioxidant activities. The next, please. Antibacterial, antiviral, antifungal, antiprotozoal, antitrypanocidal, in the other activities report in the literature. The next, please. Therapeutic activities in dermatology, stomatology, diseases caused by microbial contamination, and in dentistry. And the next, please. Different kinds of microorganisms were strongly inhibited for this kind of propolis. Staphylococcus aureus, epidermidis, Banharella catarrharis, and Bacillus cereus. E. coli partially inhibited in Klebsiella pneumoniae was not inhibited in this by this kind of propolis, and many other microorganisms. The next, please. This is a report from my research group about artepilin C as a cinnamic acid derivative, the most important compound in Brazilian green propolis, responsible for antimicrobial and antioxidant activity of green propolis. The next, please. In 20 clinical isolated of Staphylococcus aureus, we proved that the greatest antimicrobial activity was in the ethanolic extract of propolis and the ethanolic extract of Baccharis, of course, because the chemical composition is very, very similar, and the MIC values were very, very interesting. And we conclude that we have synergies between different kinds of compounds in this green propolis responsible for this activity. And now we are investigating another kind of compound belong to the volatile part of propolis, green propolis, that is very interesting. And this compound has a very, very good antibacterial activity too. The next, please. Antifungal activity, we have two, and in this report, we can see the synergies between propylene glycol with the propolis. It's very interesting. The other, please. In Trichomonas vaginalis, Giardia lambia 2. The next, please. And against many kinds of virus, for example, poliovirus type 1, influenza, hepatitis, herpes virus type 1 and type 2, and dengue, virus involved in dengue, and in coronavirus of animal origin too. The next, please. These information, all informations are published in these articles. For example, antipoliovirus. The next, please. Yes, the next. Anti-influenza. The next, please. anti-AIDS, Brazilian green propolis. The next, please. And the caffeochinic acids are acids in this kind of propolis. They are typical in this kind of green propolis. Caffeochinic acids, we have more or less 5 or 6 different caffeochinic acids. They are potent against against influenza, and they have a very remarkable antioxidant activity too. The next, please. Anti-tumor of propolis. Other, please. The other. In immune system, I think that many research will be lectures here about the immune system. The other, the next, please. And now, during the epidemic of coronavirus, we can see a lot of different reports on the scientific literature about the efficacy of propolis against this virus. The next, please. This is the next, a computational in silico only study of propolis and honey constituents against coronavirus. The next, please. It's not from Brazil, but the next. This is a clinical study developed in Brazil by Dr. Andresa Berreta in collaboration with a hospital in Bahia about the efficacy of propolis used with another medicines and using with the medicines against coronavirus. And they conclude that it's very important to use propolis because the time to be good is decrease and the people feel very good. The next, please. I'm finishing. And this is another publication about studying silico of propolis and bee honey. The other, please. And this is again, but not a Brazilian study with the Brazilian propolis. The next, please. And now, before I finish my lecture, I would like to show to everybody the Brazilian propolis in dentistry against pathogenic bacteria, fungi, and other diseases. The next, please. We can see here the efficacy of green propolis. We published this review. Me and my colleagues in Brazil, we published this review about green propolis, the efficacy against Enterococcus, Streptococcus, and Candida albicans in studies in vitro and other in vivo. This is only a few information about this article because it's big. There are a lot of information. The next, please. And here is about red propolis. Red propolis is more effective than green. Its propolis has a very good antibacterial activity against Candida, for example, and other kind of microorganisms. The next, please. And to finish, I would like to conclude informing that bee products are perfect adjuvants for the maintenance of human health, have remarkable biological actions. That's the reason they are the subject of many studies, especially Brazilian ones, due to the important biodiversity that exists in our country. The next, please. I would like to thank you, especially to Dr. Stefan Stangaciu, to invite me to do this lecture. And the next, please. Here is my email address from the university. And thank you so much for everybody for this time, to spend this time to listen and to see the information. Thank you so much.
Yes. It was an excellent presentation, Professor Maria Cristina Marcucci. My heart is so full of joy and love, and thank you very, very much. It is an honor for us to be with us here.
For me too. Thank you.
Yes, yes, yes. What do you think, Professor Sibel, about this presentation? Any questions, maybe?
Of course, excellent. Thank you very much.
Thank you,
Professor Marcucci. We read your articles, and they are also very excellent. Thank you very much.
Thank you.
And you summarized all of the honeybee products and their antimicrobial activity. Thank you very much for
thank you too.
Last session. Thank you very much.
Yes.
Thank you too.
Yes, we can open some questions. We have 10 minutes more until the break for the dinner. So you can open your microphones or your cameras and let's discuss a bit on all presentations which were before, or maybe some comments. I saw here in the chat.
Yes, so Dr. Stefan Stangaciu, I would like to discuss this sentence, the information from Mr. Ervis about the alcoholic extract of propolis. Many people ask me about the use of ethanol to extract propolis. The ethanol is very interesting, but because we can extract all, in my opinion, all important compounds in propolis, but it's not so good for many people who use alcohol, and many people don't like to use ethanol. So I think that your comment when I started my lecture is very, very important. Maybe you can dry the ethanolic extract to evaporate alcohol and then use oil, for example, olive oil or thyme oil that is very interesting. I love this kind of oil and use it. Because it's very interesting and it's not toxic.
Yes, yes, very, very correct. And even if you evaporate the alcohol from the propolis extract, we cannot evaporate everything. And indeed, there are many patients which cannot tolerate the alcohol. And Turkey has also very good experience with making the extracts. For example, there is one research there. They extracted propolis in essential oils, like essential oil as a liquid used as a solvent, and they put propolis inside and they extracted from propolis the essential oils from propolis and the aromatic components very well. So there are many, many options to use nowadays instead of alcohol. Yes, what do you think, Professor Sibel, about this kind of things? And maybe Tariq, you have a comment, and Salomoon, Ipav, we see here new friends in the area. So Sibel, what do you think about these extraction methods?
Yes, of course, Stefan. You know that my favorite solvent is olive oil in these days. I study on olive oil extract of propolis. I tried many different extraction methods, and concentration, also other anything, many things. And now I can say that yes, olive oil is excellent solvent, because when you use cold pressed virgin olive oil use, you know that many important bioactive molecules comes from olive oil. For example, oleuropein, hydroxytyrosine, caffeic acid, ferulic acid, vanillin, much more compound, also carotenoids. You know that also olive oil alone has antibacterial activity, antioxidant activity, and we see that in cooperation with propolis, synergic activity, and I saw that antioxidant activity higher than ethanol extract of propolis. This is very important results because we know that ethanol is dangerous, maybe I can say dangerous for sensitive people, for example, for children, for cancer and liver disease, and how can I say, another disease I can say. Therefore, maybe in sensitive people, for sensitive people, we can use olive oil extract of propolis, because activities, for example, antimicrobial, antioxidant, anti-cancerogenic activities of olive oil propolis higher than water extract. This is important point also.
Yes, I agree with what you said. Now, in the practice, in the apitherapy practice, there is one important principle. We need to reach the target. So where is the organ? Let's say it's a far away organ from the mouth, like the kidneys or the bones, with as much as possible from the active components. Okay, so probably some other extracts like water extract will go faster to that place. Oil extract, which is oily, in my opinion, I think is very good for the skin, for the mucosa, for all those places where you can go, like protection from external. But to go very deep and very fast, like green propolis, which is more water soluble, much more water soluble, and water extracts maybe go deeper. So maybe some pharmacodynamic studies will be good to do, like to see what goes deeper in the body and faster. This extract, or this extract. What do you think? Yes, activate your microphone, Maria Cristina. You agree with what I said?
Okay, Dr. Stefan. Thank you, Professor Sibel. And I would like to speak that, to talk that olive oil has omega-3, 6, and 9, and they are very, very good antioxidants. And I love this kind of formulation. Use extract propolis in ethanol and dry and put in olive oil. I love this formulation, but it's Dr. Stangaciu said, for example, to use the aqueous extract of green propolis. It's good because the aqueous extract has a very interesting antioxidant activity, because we can extract all caffeochemic acids, including paracumaric acid too. But this kind of extract is more sensitive to fungi, and the stability is not good. If we can dry the extract, it's perfect. But if we don't, it is not possible to dry the extract, it's not good to use this kind of aqueous extract. In Brazil, some industries produce this kind of extract, but they use conservants such as benzoic acid, for example. And it's not natural. in my opinion, it's not natural.
Yes. Yes, maybe one practical solution is you make fresh the water propolis extract.
Yes.
And use it quickly. Or
Yes.
maybe if you mix a small amount of the water propolis extract in honey, like put like 2-3%, and honey is very dry.
Good.
Then it will absorb and may stay a bit longer.
Yes. In Brazil, and some enterprises now are producing capsules, oil capsules. They extracted propolis, dry the ethanolic extract, and mix with oil and put in the capsules. And this is very interesting too, because this formulation is without ethanol. In my opinion, that it's very interesting.
Very good, very good. Yes, Nariman, what do you think about this debate on the alcoholic extracts or olive oil extract? Or
I think that Dr. Sibel find the best alternative for me, which is olive oil. It's I think I will use the same approach than Professor Sibel, because olive oil when we use it only in some illness, it's very, very active and effective. So when we combine it with bee product, I think we will have a very, very interesting mixture, because bee products alone are very interesting, and olive oil is very interesting, and the mixture will be perfect for us.
Yes, yes. I have in mind here a special extract which is from Russia. I said I will not pronounce anymore the word Russia because of the war with Ukraine, but let's give what is important to the scientists. The Russian scientists, they found out many years ago that butter propolis extract, like you can extract propolis in olive oil or other oils, but also in butter. And they found out that if you make this extraction, and it's very simple, it's 1:8. So 1 part is raw propolis and 8 parts is the butter. And you put in water bath at about 60 degrees Celsius, and you mix it non-stop about 2 hours, because propolis does not go very easy into butter, but finally after about 2 hours it goes into butter. And they use it very, very well against tuberculosis. And with very good successes. And the comment here is that the people with tuberculosis, they are very, very skinny. They are dry. They do not have enough fats in the body. So whenever they need fats, so butter is fat, olive oil is fat. So we can have like a group of patients, the skinny, the smokers, all these people which are having some problems with less amount of fats in the body, they will benefit probably better than from the alcoholic extracts and so on.
Yes, of course. Okay.
Very good, very good. Okay, so here is a question from Solomon Ipav. Ipav, we can also ask you activate your microphone. Solomon, can you? Yes, you can put a question directly. Yes.
You can't imagine how excited I am.
Hello.
Because finally I'm putting the faces to the names I've been seeing all over.
Yes, very good, Solomon.
Yes, Professor.
Nice to know you.
I'm so excited. I'm so excited now. There's something I had my question posted on the chat, but now that I have an opportunity, I could maybe just say it out. I'm thinking that we can deliberately improve on the properties of propolis, maybe by planting the trees that would yield certain properties. Like you cited an example of green propolis, having I think Dracunculifolia as a basic plant, and then you said It is water soluble. Of course, it looks like it has, in terms of water solubility, the property, it has better property than red propolis. Now, we can improve on the properties by bringing trees that yield red propolis to come and plant around where we have green propolis. So I'm thinking that we could have water soluble properties of red propolis. Is it not possible?
Okay, okay. You are speaking about the soluble compounds of red propolis, because my computer has a very bad sound. It's very difficult to understand.
This question is very important to me. Let me come again, ma. Please. Can I?
Sorry, what do you have?
I say the question is very important to me. Please, may I come back? May I still say something?
You want to show us something?
No, it's like she didn't get me properly, and I want to really get this across so that she can show more light.
It's very difficult to listen.
Okay, look at the screen. I've written something there. Just look at, I've written something there. You can look at it.
Yes, there's a question on the trees,
yes,
which are good for the propolis. Okay. So let me answer to this idea, because I read also the comment in the chat. So of course we need to have near the apiary as much as possible medicinal bee plants, which we need for a certain disease. Now, from the practical point of view, you need hectares, you need large amount of trees. So because the bees, they fly like 3 kilometers away, they go all over on, I believe, 27 hectares or more. So if you plant near the apiary 2, 3, or 10 trees, it's not enough. So in Europe, in several countries, what are doing the beekeepers? They go with their trucks. Where are the big forests? So they know that, for example, in July, in this part of the country, the linden trees are flowering. So they go with thousands of bee colonies to that place. So, but for Africa, for you, what you can do is to speak with a botanist and ask the botanist, which knows everything in your country, to tell you where are the big forests of this tree, or of this tree, or of this tree. Then you make a strategy. You say, okay, so this tree, eucalyptus, is very good for this and this. Okay, when is eucalyptus giving more raisins and so on? In this month. Then let's go with the beekeepers to this forest. Okay, but for the didactical aspect, this is a $1 million idea, and I learned it in Germany. You may have like a botanical garden where you have, let's say, 100 different trees and plants which are medicinal and are good for the bees and human beings. Then you invite all the faculties, the students, the pharmacists. You go, you make the tour in your garden, like step by step, to all these trees, and you explain, this one is very good for this disease, this one is good for this disease. And we have here, for example, in Romania, in Bucharest, a botanical garden, and they put the plants according to the organs. For example, plants which are good for the liver, plants which are good for the heart, plants which are good for the stomach, and so on. Okay. But there are many ways to do it. So maybe we'll speak after the conference with all our experts. What do you think, Maria Cristina?
Yes, but I would like to conclude your speech, Dr. Stangaciu, speaking about to this colleague from Nigeria, that we have a very interesting example in Brazil. The Japanese, some people from Japan, more or less 20 years ago, bought land in Brazil and plant Baccharis dracunculifolia and put a lot of hives there. and they produce a very bad propolis with a dark color and not so good, because Baccharis dracunculifolia is an invasive plant. Because this plant is invasive, the conditions in the place is not so good for them, and then produce a lot of secondary metabolites. And this is the reason that we have a very interesting propolis, green propolis, because this plant produces a lot of secondary metabolites, because this plant is invasive. And bees prefer the resin of this plant. And I would like to speak to this colleague from, I don't know if from Selumon, that your information is very, very good. And he needs to looking for researchers in his country that are interesting to evaluate the chemical composition and biological activity of propolis from his country. It's very interesting because we have a lot of studies to do in next years, because we know only a small part of this universe of propolis all over the world. This is my opinion.
Thank you very much, Prof. We are currently working on that. And we have a team still under Professor J.O. Igoli. Sandra that presented is in the same team with us. So we are working on it actively. We hope that Dr. Stefan will bring Propolis and the team, the conference, to Africa and Nigeria. We are waiting to host you.
Yes, we will come, all of us, to Nigeria, for sure.
Okay.
Yes, and it's true. I saw here in the chat, Professor Tiziano Gomez said that we need a real multidisciplinary team, and maybe also a geologist to study the soil, because you are right,
Yes.
Maria Cristina. I know in Minas Gerais, Baccharis grows very well on that soil, which is very rich in iron oxides. So if the soil is not good, the plant cannot grow so well. Yes.
Yes.
Okay.
Great, Dr. Stangaciu. I have another example. In Minas Gerais, we have these kind of compounds, artepilin C and paracumaric acid derivatives. And in Paraná, we have the same propolis, but we have one more compound in this kind of propolis. One more. Only one. This is the fingerprint of green propolis from Paraná.
Okay. Yes, wonderful. Professor Tiziano, what do you think about this multidisciplinary team working?
That's very good presentation, Marcucci.
Thank you.
With
Thank you so much.
Propolis, pollen, and the honey. It's a good news about the COVID, propolis, and the bee products in COVID. We try some studies here in Alagoas, but our team is not necessary. It's necessary other professionals in health to develop studies, clinical trials. But I'm very happy because in São Paulo, Andressa Beretta and the Sforcin get some studies. I'm very happy. And I think the chemical composition of propolis, I think it's necessary study not only one plant. The bee hive, it's necessary diversity of plants. Because for example, in summer, the bees visit some kind of plants. In winter and the spring, other kinds. It's necessary to the bees. It's necessary to survive in the forest. It's a stress for bees, difference of seasons. So I think it's necessary for beehives, necessary diversity of plants, not the only one plant. And, for example, in União dos Palmares, the work with União dos Palmares, November, there is a semi-aggression. This is the Baccharis, trinervis, and the Baccharis cinera. It's not the Baccharis dracunculcifolia, but Baccharis trinervis and Baccharis cinera. Broad, there is a flowers in this epoch of year, November, December, January. And we will try correlate the plant flowers and the composition of propolis with some articulin C and the phenolic acids. But in winter, in the rainy season, there is the camellia citrucinensis, laranja, orange, in the plantation. And there is we observe 2 peaks of phenolic compounds and the metabolics. January and April or May. These peaks is related to the saffra, the plantation of orange in April, May, and in January, it's for example, other kinds of Baccharis in União dos Palmares. So it's necessary, the diversity of plants will get more diversity of compounds and the survival of bees, and will get more metabolic, secondary metabolic for diversity of the biological properties of propolis and the bee products.
Very good. Thank you very much, Professor Tiziano. Very good idea. We learn a lot from the bees. So we should think that we are living in a beehive and how can we survive in different seasons and so on. I remember one study done in Argentina on the poplars from the mountains, from the Andean mountains, high in the mountains, and the same poplars in the sea level. And the poplars which were on the mountains were stressed because less oxygen, but also more ultraviolets. So they produce more polyphenols, more flavonoids than on some ocean level. Yes. So
it's true. It's true. I agree.
Yes. Yeah, so one principle we use also in apitherapies, we need to use the products, the bee products from our region where we live. If we live in the mountains, then we need more protection with polyphenols and flavonoids. So we should eat or use the products from the mountains. If we stay in Indonesia, we need products from Indonesia. So of course, there are always some exceptions. And one exception is, for example, I have here in Romania a patient with cancer. I know that my Romanian propolis is very good against cancer for this and these reasons. But I know also that Brazilian propolis, red or green or brown, it's also good against cancer, but through other mechanisms. So in this situation, I recommend to my patients to buy all these different products for a better synergic effect against the disease.
Yes, yes, it's
Yeah.
true.
Yes. What do you think, Tariq, about these comments? You are quiet, but you have also good practical knowledge. Tariq is in Bahrain, and he uses the bee products also for a long time. By the way, Tariq, because I remember now, Tariq has a cheetah, and he saved the cheetah against one infectious disease. Can you please explain us, give us the story?
Sure. She has a co-infection of Trichomonas fetus, which is close to Trichomonas vaginalis, and she also has Clostridium difficile, which is a superbug. I used beehive products to treat her. I started with Manuka honey. I tried Propolis and I tried bee venom. Propolis, I used Propolis powder. I used first the Chinese one. It did give me an effect. It did give me an improvement, but it stopped because she cannot handle the taste much, really. Okay, so and then I tried it with Manuka honey, UMF 20 plus I added bee venom powder to that because it affects the Trichomonas fetus, and it helped. Like from 20 diarrheal episodes per day, she's having like once. So that's a big improvement here. So.
Okay, very good, very good. It's we have so much knowledge, scientific knowledge from so big brains like yours, but we need to bring this knowledge on the practice. So on real situations. And like Tariq, you saw he used several systems until he found the best solution. But it's wonderful to have all this kind of extracts, all these kind of products. And nowadays with internet, we can order them pretty fast. So maybe it takes some time to get them, but we can do a lot of wonderful things. Yes, wonderful, wonderful. Nariman, what do you think? We take now the break, the dinner break, and then we come back for the final discussions. We already had a very good discussion here, and but after the dinner break, let's come again a bit. So, what do you think, Nariman?
Yes, we can do this.
Okay, so yeah, let's come back after 30 minutes. Yes, let's take eat some calories, and then come back. Okay, so I will close again the platform to allow the registration, the recording, and please come back with the same link to the same Zoom conference room. Okay, thank you very much. See you soon in 30 minutes.
Thank you too. Thank you too.
Okay, thank you.
Bye-bye.
Bye-bye.
See you soon.
Thank you.